Good afternoon, everyone, and welcome to the session, Tech Trends in Artificial Intelligence and Information Solutions, the role of information solutions in artificial intelligence applications, in the frame of ConRecit Virtual Week. My name is Pedro Gallardo, a Solution Sales Manager from Elsevier, and first of all, I would like to thank, on behalf of Elsevier, to the National Consortium for Scientific and Technological Information for inviting us to partnership with them at this important event for the scientific community in Mexico. Elsevier, as a leader in information and analytics for customers across the global research and health ecosystems, welcomes you to this one-hour session. It is important to underline that we will have some minutes at the end of the session for Q&A, so please feel free to send your questions at any time during the presentation. It is an honor for me to present Dr. Marius Doornenbal. Marius Doornenbal, PhD, is a trained linguist turned data scientist, with over 25 years of experience in information retrieval, text analytics, and all varieties of natural language processing. At Elsevier, he holds the position of Distinguished Engineer, which affords him the privilege of working alongside several teams, integrating cutting-edge artificial intelligence technologies into Elsevier's applications. The combination of Elsevier's content and databases with extraction and summarization technologies continues to amaze him daily. Dr. Doornenbal has built several artificial intelligence applications applying all forms of machine learning where applicable. While leading R&D and data science teams in industry, he has also authored several publications and patents. He is a resident of the Netherlands currently, but has spent considerable time in other parts of the world. He has a family, and his current hobby project is the restoration of a house in the woods. Welcome, Dr. Doornenbal, and good evening to you, as it is already late in the Netherlands. The floor is yours, sir.
Thank you very much, Pedro. Thank you also to the ConRecit Consortium to have us, Elsevier, talk about this very important topic. It's a privilege and an honor. Thank you. Today I will be spending some close to an hour with you. So let's make good use of this time. And talk about artificial intelligence. As you know, this is a topic that has attracted incredible attention all around the world, and it's just the thing that is very, very popular. I will spend this upcoming hour talking maybe 40-45 minutes to talk about what artificial intelligence is. So what is it that we talk about? And then after we've sort of defined what this is about, I will review the research into artificial intelligence, and then I will look in what happens worldwide in industry, and also I was able to see what it is like in Mexico. And then, if we are lucky, and I hope we are, I planned to get lucky, we can dive into a specific application of artificial intelligence. And that is an application that I'm most familiar with, that is the easiest for me, the application of information solutions. Why is artificial intelligence so effective in that arena? And how is it done? So it may even get a bit technical if we are lucky. So let's try to understand artificial intelligence. It's a branch of research in very broad terms that concerns itself with the making of machines that solve complex problems in a human way. So, and we think of human intelligence as something quite remarkable, which is sort of maybe right or maybe wrong. But we think of complex problems as playing chess. And if we see a computer play chess, we think that is better than humans. That is remarkable, and that's artificial intelligence. And the human part in that strikes us. But actually, it is superhuman because humans lose against the computer. The computer plays better. And that is not the only piece of artificial intelligence that makes it intelligence. It's not like only typically human tasks are the tasks that artificial intelligence solves, or even in a human way. So the most effective artificial intelligence applications do things that humans cannot possibly do. And they are just larger brains than ours, specialized for specific tasks. An elephant has a bigger brain than humans. And that's for a very good reason, because actually the operation of the huge body that an elephant has is far more complex than the operation of a human body. It doesn't have the decision-making part of the brain as developed as the human brain, but the operation of the trunk is just as complex. And that's a way we can also think about artificial intelligence. So if we have say, a calculator, a very simple machine that can do math much quicker than we can do it. It's a piece of specialized artificial intelligence. We would never call it human intelligence. And that's why we make a distinction between specialized, narrow artificial intelligence and general artificial intelligence. So computers outperforming humans in every aspect. The general artificial intelligence is not a reality. The specialized artificial intelligence, the narrow AI, is very much a reality. Computers can perform certain tasks much more effective than we can ever hope to do. Artificial intelligence is, I think, a very important topic to have to discuss, because it is highly popular, and that can be seen in many ways, in all sorts of ways in the world around us, but also in research. So to get a view on that, I went to my most popular platform for analyzing research, which is SciVal. It's a product by Elsevier, scival.com. You can look it up. And it's really fast in pulling out information on what is happening in the world of research. So this bar graph is very simple. It shows you a clear ascending line in the number of publications related to artificial intelligence. Of course, that doesn't tell you much, because research in general grows. But I will have you know that research, according to a report by Nature, and that's not Elsevier, so this is a neutral source, research output doubles every 9 years, but AI research output doubles every 4 years now. So it grows much faster than average research. And that, in my view, is even an underestimation, because what we see happen in research is that almost no research happens without using artificial intelligence. Artificial intelligence as a field of research has this trend that you see right here. But artificial intelligence as a method for research is everywhere now, even in humanities, literature research, history, archaeology, every field of science uses artificial intelligence. So this bar is flatter than reality. And Elsevier, as a science information solutions provider, of course, has picked up on that. So this is a very pretty diagram, very colorful. That's part of the artificial intelligence report that Elsevier has put out already 2 years ago. I guess there will be an update any day soon now. And it was an innovative report in the sense that it really built the understanding of the field from the ground up. So we had the computers read all the text and discover what topics were discussed in all of the artificial intelligence research output. And what you get is this sort of diagram where you can cluster those themes around specific fields and topics. So you see that there is the neural networks. I guess this is a concept that many of you will have heard of or be familiar with. There's a cluster of computer vision, search and optimization, and so on. And the report goes on to describe this field in much more detail. And the interesting thing about this report is, of course, that it was created using artificial intelligence to get that view on the field of artificial intelligence research. Now back to the trends. So my favorite tool, I already gave it away, is SciVal, that produces those fancy reports. And of course, because of the audience, I wanted to know what happens in Mexico. And as you can see, Mexico is number 29 worldwide, according to this research analytics tool, in terms of output, scholarly output. And it's clearly on the rise, clearly, more or less slightly below the research overall trend, not quite doubling the output, but definitely on the rise. Now, you think this is good, but look at this. Your northern neighbors, of course, they're bigger and they have more output in general, but not only that, also the output increases much more steeply. So it grows, but grows faster. And you think that is impressive, then look at this. This is China. China is not only bigger than the USA in terms of artificial intelligence output, but also grows way faster. So that is clearly a country that has put its priorities on the development and research of artificial intelligence. So that's good to know, and definitely a challenge. So where does the AI research happen in Mexico? If we look at the numbers again in SciVal, then we see that the top institution is the IPN, the Instituto Politécnico Nacional. And even the 2 top positions are taken by that institute. So the second is the research branch of the same institute. And together they make up, I guess, for half of the total research output. And also the UNAM deserves a special mention. It is the most reputable university of Mexico, according to the Times Higher Education report. But it's not the star in artificial intelligence. And that is simply because this university is not ranked highest for computer science. It doesn't mean they don't use artificial intelligence in other types of research, but the output is modest. They did, however, I should give them honorable mention, put a very interesting conference out last year where they discuss AI as a method. And that's they wrote in the invite there that the new progress in AI and machine learning has provided new ways to process large data sets, and the new techniques are particularly powerful when dealing with unstructured data or data with complex nonlinear relationships. So clearly, it is understood that the method of artificial intelligence is very applicable to all fields of research, also there. If you look at, if we zoom in on the map in Mexico, we can see that there are some star performers, and one particular person stood out. You can easily get to him in SciVal because he's so significantly present for Mexico. A certain Professor Oscar Castillo, I looked him up and saw that he's a leading expert in fuzzy logic. So there are people really with international reputation working in Mexico. Also, something that was of interest, and I will explain later why I thought that was interesting, was the application of AI to agriculture. So, and I believe what I understood that may happen in Jalisco. So that's a very interesting application. Also because that may be a very significant, unique, strong point for that university, for that application, because it's not done everywhere, this application of artificial intelligence to agriculture. So there are many ways to get to this information, and I hope that you will get away from this conversation we are having with a desire to look up artificial intelligence research or people or institutions in Mexico. So where is that happening? And there are several ways of doing that. And of course, I cannot skip the opportunity to show some Elsevier tools that allow you to do exactly that. So this is a screenshot of the tool called Engineering Village, which allows you to search and really drill down into great detail for specific technical questions or queries. And the benefit of such a platform is that it gives you authoritative content, curated content, relevant content. So it's not, of course, Google is everyone's friend. I guess everybody is familiar with Google even as a verb. I will Google that. But there are specialized tools that will allow you more refined searches and drilling down into institutes, people, specific fields. And those tools are controlled by defined vocabulary, so that you can define exactly what you want to talk about. And I will talk a bit more about how artificial intelligence can be broken down to understand the field in more detail. And that is exactly how it is laid down in a controlled vocabulary. So you can say, I want artificial intelligence specific for neural networks. And that brings you the people or the exact results that you're looking for. And also the institutions, if you're after that. So that's how this kind of tool works. It really allows you to go into detail. Good. That's Mexico. Enough about that. Let's spread the net a bit wider and look at your northern neighbors. They're not a good example for everything, but in AI, clearly they have done some good work, admirable work. And there's a lot of research, and many people are surveying the market for what is happening there. And so does Realix, the same company that I work for. And they are observing, and they do this every year, that the investment in AI does not slow down, not even during the economic downturn that we are now seeing due to COVID-19. So even in the face of this pandemic, people are still spending more money and putting more emphasis on AI. And all the trends are up. And that's because it is not just the field of research. We have discussed research for just now, but there's also a lot of application, because businesses, they want that to automate their processes, detect fraud, waste and abuse. There's no fraud detection almost anywhere without the use of artificial intelligence tools that discover patterns that are some way suspect or out of the ordinary. So, that's why the businesses are looking at that. And as it goes, the business need often drives the research agenda, and that's not a bad thing per se. Now, here are some trends that are in that report that I just introduced, and they're nothing like you would not expect. It's everywhere. Government is slow to pick up, healthcare also slow, and there's a reason for that, because the constraints are very high in healthcare. You really want to get things right. People have a lack of trust sometimes in systems. But in science, it goes very fast. Legal, very fast. Banking, very big. And there's one outlier here, which is sort of interesting, and that's agriculture. And that's why I mentioned Jalisco the other minute. That may be an opportunity. A similar research was done by the MIT in the United States, specific also for Latin America. And that was a very interesting research, very similar to what RELX had done. Latin American businesses are mostly looking at business optimization as a driver for AI. And that's also where they will target their AI investments. So getting your supply chain faster, etc. Real practical transport, e-commerce, of course. E-commerce is very big, and travel and banking. The MIT also observes that Latin America would benefit, this is their opinion, not mine, would benefit from more structured national planning of AI efforts, and political volatility is a detractor. So, finally, and this is also something that comes out of the RELX report, and I really wanted to mention it specifically, is that the absolute majority of businesses or researchers, I don't think it matters who you ask, put a strong emphasis on ethical consideration in AI. I think that worldwide we are becoming increasingly aware of the downsides of AI. So, and that these ethical considerations are a topic on their own. So I sadly do not really have the time to dig in as deep as I would want to. But it is, you have ethical considerations to make in designing a system, how you predict values, how you select fraud cases, how you do these things, how you present content to people, is a design question that has actually ethical implications and considerations. And also, of course, there is the Netflix show you may have seen, El Dilema de las Redes Sociales, that highlights the definite downsides of filter bubbles or algorithms presenting you content through Facebook or other companies that have socially negative effects on people's behavior and information consumption. And this is also a thing that the OECD tries to push to the member states for better policies. So that is the survey. Now let's take a deep breath. I'm going to take one. And let's try to understand this field a bit better. We sort of know it's important. We know what people want from AI. How do we break it down? How do we search for the right type of information? I'm a researcher. I need a specific solution. I want to build a startup. Who do I call? What are the key concepts? How do they interplay? How do we get the resources we need to do research on AI? I like to think of it in a structured way. So people sometimes equate artificial intelligence with machine learning. It's not the same thing. Artificial intelligence is a field that has techniques. So you have a technology that you want to pursue to solve a particular problem, to perform a function. And that technique, the technology, does not have to be machine learning, actually. It can also be knowledge engineering. Like I write a set of rules, and even if I do machine learning, there are different ways of doing machine learning. These are technologies, and these technologies are very close if you go dig deeper, even to mathematical concepts. So that's on the method side. That's how you do business, and I love to talk about that. But that's one aspect. You can't equate artificial intelligence with machine learning. That's just one of the ways of doing business. These technologies perform functions, and those are the things we need to build together, to piece together with building blocks an application. If I want to have a self-driving car, I need to see the world around me through computer vision. I will have to also perhaps process signals from the car, feedback, motor, brakes, systems control. I will not have to do the function of text processing unless I want the driver to instruct the car by voice. If I want a voice-operated self-driving car, then I will need NLP, text processing. So those are functions. Those functions may use similar techniques or entirely different techniques, but those are functions. These things together compose applications. Applications are the things that we use. We don't need a hammer. We don't need nails. We want a house to live in. That's an application. And of course, those are the things that we see around us and that people tell us these are driven by AI. And they are self-driving vehicles, automated factories, crowd control, diagnosis support. And interestingly, those applications are very different from one another. You can't put them logically together. But diagnosis support and automated factories may both rely on a technology that is called support vector machine in supervised learning. So you see that this field can be broken down into these particular aspects, and it helps to understand the field. It also helps to see why this research in artificial intelligence is sometimes extremely interdisciplinary. So people from one discipline can take concepts from another discipline very easily. If you look at how this is done in the information retrieval applications that Elsevier builds, we organize these things through a hierarchy. And we have technologies that that are very close to even mathematical concepts. And that's one branch. And that's where you can take a few terms to slice your search. And then again, there are a couple of functions you can select from another branch. And these things together define and narrow down what you're looking for. To show you how interdisciplinary the field is, this is just an illustration, so you don't have to remember it per se. PyTorch was put out by Facebook after Google put out TensorFlow. You see two commercial players putting out tools into the market. Interestingly, TensorFlow was first and was highly popular. But then, suddenly, PyTorch was put out and people started using it. Now, the red line and the green line, are very different fields of research. ACL, that's the computational linguistics. This is language processing conference. The adoption of this new tool follows the exact same trend as the red line from CVPR. That's the computer vision conference. So two entirely disjoint fields using the same technology. So that's how interdisciplinary it has become. So, like I said, it's the big companies that now put out those tools. And by big, I mean really, really big. And not because the money is so big in those companies, but because the resources they create, the artificial intelligence models, the models that people load into their computer to do a specific computation. Those models are very hard to create. And to achieve a certain level of performance, suppose I want to have a model that perfectly recognizes animals. I show it an animal, it gives me the name. You know that to achieve some model, we know how it's done. But to train the model, you need an immense amount of data. And you need to train the model for a very long time. That's how machine learning works. And if you want to reduce the time, add more computing power. If you want to improve the performance, just increase the model size. Now, people have done some math, and I'm taking this information from a good source. For example, Hinrich Schütze from Stanford, I'm not sure Stanford, California anyway. And the people who put out OpenAI initiative supported by Elon Musk, they have done some math on this trend of building large models. And they have figured out that to improve the performance given the current state of the art, to a 1% quality loss on an image recognition task, you can compute how much it would cost to have a 1% quality loss for image recognition. This has been computed to cost over $100 billion. Of course, no one has done that, but it's mathematically correct. That's how much it takes to build this near perfect model. And that means that only big companies can do those things. So last year, you may have heard about the GPT-3 model, which is a language model. And if you have time after this talk, you can Google it. A language model that sort of can just tell you a story. You give it a sentence, I went for a walk, random sentence, and this model will just create a story out of that, which is amazing. an amazing piece of artificial intelligence. To train it, this cost $10 million. That's the state of play. The good news is that bigger is not always better. And all of this muscle is not going to yield the best results in the long run. Just making stronger models doesn't give us any more insight in what intelligence means, or it doesn't also does not give us insight in how we can do this more efficiently. So the more fundamental research is not restricted and will never be restricted to only the big boys with the strongest muscle. The other part of good news is that these big models can be increasingly shared and reused for other purposes. So Google has done the work, and we can reap the fruits. So that's a bit of a consolation for lesser resourced companies such as my own. So let's see. Let me dive into a bit of detail here and talk about my favorite subject, which is information retrieval, information solutions, and research information dissemination, spreading of research information. What you see here is a graph done by the science, technology, medicine publishers, where they have tried to map out what the tech trends are for the future. What do people expect from research information, and which way is this landscape moving? And you see a trend towards personalization, fine, but also many of these themes touch on, I want information in the right way now, and I want it to be digested. I cannot handle so much information. I want things to be easy. Many of these things rely on artificial intelligence to be applied to information solutions. There are many aspects to this, so there's no way that I can touch on all of these. But a couple of them I think are very familiar. Recommenders are very familiar. Everybody understands that if I have ordered one article from Amazon, it will recommend me another that is close to it or somehow related. The same is true for information. If I've searched for one thing, the system, I expect the system, this is an expectation in 2020. I expect the system to present me with related content. Also, in a search, if I now search for Albert Einstein on Google, I get his picture. Similar expectations are now a reality in research information solutions. Of course, we expect that. We are used to it. So that all supposes a whole deal of artificial intelligence. And this is a piece of artificial intelligence that is focused on the processing of natural language. Humans such as you and me, we speak a natural language. We talk using words, and we are very comfortable with that somehow. But computers are not. For computers, this is very hard. For computers, text is unstructured information. And this is a challenge in artificial intelligence that is extremely large, unsolved, and from my personal perspective, very interesting. It is also an intriguing part of AI, I think, because it is so closely intertwined with general human intelligence. If we want to have a computer that deals with text in the way we do, that is perhaps the closest it can come to human-like behavior. And yeah, to talk about natural language processing, I'm going to take you for a ride to talk about image processing. Now that is interesting. You will think, why are we talking about image processing? Well, something happened in image processing, and it's called ImageNet. So like 10 years ago, the challenge had been there. We want to recognize pictures. Maybe this is already 15 years ago. Of course, we have a photo of a dog, a photo of a cat. It can't be hard to take them to differentiate. It's very simple for humans to recognize. For computers, this was very, very hard. This was a problem that had a 25% error rate. So you're looking at the diagram on the right-hand side of your image. 25% of the time, computers got it wrong. That's hard to imagine nowadays. So what then happened is ImageNet. ImageNet was an effort to build a data set, a huge data set, which was made possible through the internet, through Amazon Turk, and Mechanical Turk. And the challenge was put out with all of these images that were labeled dog, dog, cat, horse, beach, tree. All these images were labeled, and the challenge was put out, can you recognize these? And then Jeff Hinton, a guy from Toronto, figured out a way to resurrect an old technology, which was called neural networks. And because the computers had become so much stronger in those 15 years that had passed, nobody looked at neural networks again for 15 years. But he applied that technology with much more computing power to this problem. And suddenly, these scores began to become crazy good. And computers are now better recognizing many images than humans. And that was an ImageNet moment. This is known as the ImageNet moment. And the nice surprise also was that people who trained their models on ImageNet could use these models, these neural networks, to apply them to other problems. So you couldn't just recognize the images, you could also use the models or parts of those models to apply to other problems, which is a form of transfer learning. So you transfer what you learn in one area and apply it to another area. So now the question is, how does this relate to natural language processing? Well, natural language processing is said, that's what people say, to have had its ImageNet moment 2 years ago. And that is because of the introduction of a model or a series of models that are called transformers. Oh, there they are. They're on this slide. Transformers. And transformers, you wouldn't believe it if I told you, but it's the truth. Transformers do nothing but take a piece of text and transform it into a series of numbers. And they do so in the best way they can. But how do you train them? Just numbers doesn't mean anything. So they get a challenge. You give those transformers a challenge. You say, given this number of words, just give me the next word. A model like that is called a language model. And the good thing about this challenge, I give you these words, give me the next word. Because of this challenge, you don't need to supervise it. You don't just give the machine loads and loads of text, because in text there's always a next word. So you can imagine, to predict the next word, you actually have to understand what's happening before in the text. So you have to somehow pick up on what's going on there. So these transformers, they transform the text into a series of numbers such that these numbers can somehow predict the next word. That series of numbers contains a lot of information about what was going on in the text. And that is a trick that allows us to do many, many complex natural language processing tasks. And these tasks are organized in challenges. So challenges about language understanding, the glue challenge, or now, because the first glue challenge was done better than humans, the super glue, language generation, question answering. Squad is a very well-known challenge. All of these challenges are beaten by those unsupervised neural network models that just learn the next word. Interestingly, though, a problem that looks quite simple hasn't benefited so much from this glorious new model. And that's the subject of natural named entity recognition. So somehow it's easier for computers to return good answers out of data set, better than humans can do, than just to identify the things people talk about in the text, which is the task of named entity recognition. In the named entity recognition, the performance of computers sits around 1992, that area. For question answering, computers are much better, but that may have to do with the nature of the task, because humans, they don't memorize all these answers. And if there's one thing computers are really good at, it's memorizing. But named entity recognition requires apparently another type of intelligence, which brings us back to the Einstein versus elephant picture. What type of intelligence are we talking about if we talk about artificial intelligence? So has the ImageNet moment, the one breakthrough for natural language processing, come? Of course, I hope so, but people are increasingly critical of that idea. So obviously the computers are now winning many challenges, like I explained in the previous slide. But what has the world really gained if a massive neural network achieves the state of the art on some benchmark or outperforms it by a point of two? What have we learned about language if we do so? And have we really solved a problem? So the thing to focus on also still in natural language processing is quality research. Can we interpret those models? Do they do a task that we want them to do? Address fundamental questions. I'm giving you one seminal article to challenge this notion of, if we can just perform better and better, are we then gaining? And it has a very nice title, as you can see. To test machine comprehension, start by defining it. What do people actually want out of that? Finally, let me wrap up. NLP, I will be honest with you, natural language processing is not a strong field in Mexico. And if I may challenge you, please take that home as a challenge. But there's one very well-known researcher in the ITN in Mexico that I had the pleasure of meeting once several years ago already. Alexander Gelbuch, very well-known internationally. So I think that's a very good person to have in the country. Also, a final note before I wrap up, because my time is about to run out. This is a field that develops very fast. Natural language processing, as I think I have explained by now. And it is an absolute necessity. I hope that is also clear for building information solutions. To build information solutions that answer queries in the most meaningful way, you need applications that can read text and have a text comprehension, computers that can have text comprehension, such that you can bring out the information that humans need at the moment they need it. Exactly right. Or people will be frustrated and just go somewhere else. And the amount of information is so huge, the volume of research is increasing so fast. We need to do this. So at Elsevier, I am not alone. It's not like I'm even the smartest data scientist at Elsevier. I think that we have at least, well, depends on how you count, at least 100 people on the payroll who one way or another do this type of artificial intelligence engineering. And one of my favorite projects now, because it's one that I do now, is re-engineering the Elsevier's engineering platform with artificial intelligence techniques. Because we have so many data points we want to pull out of the engineering information articles that we want to serve out to end users. We need to read those texts automatically by computer. And we use rules to pull out numeric information. We use unsupervised models, neural networks to get the concepts out and classify the documents to get exactly the right answer to each user query, which is a very rewarding effort because it gets, at the end of the day, it gets served out to end users. Let's sum it up. I feel I have only skimmed over many aspects of artificial intelligence, and even the deep dive didn't go very deep. So you may have many questions, and I'd be very happy to answer them. But a few things, if you can, you might want to remember. So AI is making machines doing cognitive tasks. It's changing from a field of research into a technique, and more a method. AI research in Mexico is growing, can be faster. Mexico has some very strong players though, so look them up. With regards to my own field, remember that an information solution without artificial intelligence is no longer imaginable. I think that it's very good to realize for every consumer that what he or she reads is sorted, presented, searched, recommended by machines. And if not, you're probably disappointed at the performance of the system you are dealing with. We expect advanced answers, and you should, because there is too much information to see it through. Machine learning systems are increasingly powered by unsupervised and transfer learning. Unsupervised, just go through tons of data and learn from it. Transfer learning, learn from one field, apply it to another. Learn from one problem, apply it to another. Humans learn from others, and so do machines. Another thing I really would want you to remember is that the application of AI is a responsible job. There are too many examples of badly applied artificial intelligence. And with all computer science tasks, garbage in, garbage out. Bad information gives bad output. Good data is very important. Things you can forget is leaderboards. Nice for AI experts, nice for engineers to chase leaderboards, but it's not giving us any fundamental insights. Neural network is a technique. Maybe it gets superseded by something entirely different in 5 years' time. Who knows? Things go very fast. Forget the structure of the engineering taxonomy. I know you try to memorize it, don't. And your specific field is not very important. AI is very interdisciplinary. Steal from someone else if you can. That's how AI works. Apply AI and do so responsibly. Thank you.
Thank you very much, Dr. Doornenbal. I hope you all had enjoyed this amazing presentation. Now, Dr. Marius will answer some questions that were sent to us during or after the presentation. It is also a pleasure for me to let you know that we have with us backstage Judy Salk, our Director of Product Management for Engineering Village or Compendex, in case you have any specific questions about the solution that Dr. Doornenbal mentioned during his talk. I consider we have enough time to answer some questions. So the first one is, you may find artificial intelligence at all work levels. Does this result in loss of jobs?
Well, so far it hasn't. It's the loss of jobs we now see in 2020 is not because of AI. I think, as we know all very well. In the last 10 years, I think worldwide have seen an upsurge in the labor market. And that went parallel with an upsurge in artificial intelligence. So that relation is not very strong, if there is a relation at all. What I a history lesson here. So in the industrial age in England, they the British introduced steam-powered looms to do the weaving, and the laborers in England, they went in and crashed the factories to break the steam-powered machines that did the weaving of clothes, because they were fearing their loss of labor. If we look back at that 2 centuries later, we think that's funny, because, well, everybody now wears woven clothes that are woven by machines, and nobody has lost his or her job. We just do different jobs. And I think that's how the labor market will develop. We will move into different jobs, perhaps more challenging intellectually than physically per se. I'm not hearing you.
Again, second question. What specifically differentiates information solutions that use artificial intelligence from those that do not?
That's a nice question. Yeah. Let me give an example. Well, a very simple example. I can't quite think of a better one now. But we all know that a bike is a bicycle, and we all know that a bike is a type of vehicle. So suppose I would like to talk about to search for I don't know, bicycle repair or something, and I would miss out the articles or the documentation about bike repair just because it's a different word. That would be a very bad user experience. So we expect, and I think that is an expectation that everybody has now, we expect the computer to fix that for us. We expect the computer to understand that that titanium oxide is titanate. We expect the computers to know that. So if you search in Elsevier stuff, you would expect if I search for titanate, I get titanium oxide. That is because of the technology in the background.
All right. So one more question. How do you think AI will impact the development in Latin American countries? And do you consider the government should invest more in AI in the future, even more than they do right now in conventional research?
Yeah, that's an interesting question. So what you see around the world is that governments build an ecosystem for AI. I don't believe personally in government investment in specific areas, but I do believe that the government can create conditions that are beneficial for startups and for entrepreneurs and for smart people who know how to apply those techniques. So yeah, this is what happens in the United States. You see that many of these big companies start on university campuses. So smart kids, they have the equipment, they have the offices, they have no regulation, they have no bad people chasing them for taxes. They just get opportunities. And if you create an opportunity, that will make the field grow. The other thing is there is a part of policy that can be actively done in terms of pushing growth, and that is attract the right teachers. So if you look at your northern neighbors, I believe that half of the PhDs that get a PhD in the United States were not born in the United States. And that's because the United States pays a ton of money to those people to come to their country, to infuse intelligence into the academic world. So invest in smart people. That is definitely a winner.
Very well. All right, it seems those are all the questions we will address today. Once more, thank you, Dr. Doornenbal, for answering them and for the great presentation. It was a full pleasure to have you with us. So this concludes the webinar. Thank you on behalf of the consortium and Elsevier for attending. We hope you have learned something new today and had enjoyed this presentation. Have a great week, and until the next time.
Thanks. My pleasure.
Thank you, Doctor.